RBS Basic Research Academy welcomes to you in the lecture number 33. In this lecture number 33, I'm discussing about the importance performance map analysis IPMA in SmartPLS. Is another component, is another technique which is available in the SmartPLS. In through this technique, we are trying to find out which construct is like the construct in our model is important and which one is like the also its performance is good. That means that we are going to check out the importance and performance of any like the construct in our model. And I will also inform you about the 5 steps which are there in order to create informant performance map. So now this is going to be discussed in this video. So let's start this video. But before this one, my name is Dr. Rahimak Sumro and I'm from Shabbat University, Pakistan. And here you're looking my SmartPLS Academy software certificate, which was awarded to me after completing these 9 modules. Dear friends, in these PPTs that the lecture has I have developed from the by referring this research paper. It is a wonderful research paper. Its title is a gain more insight from your PLS-SEM results. So now, through the help of the performance map analysis, which is written by the two very famous researchers that are Professor Christian Gringel and the Marco Sardas. So it is a very important research paper, and then I thought why I should not share this research paper with you guys. And so now what's written over there. So first of all, is the the name of this technique is importance performance map analysis. Alternatively, we can also call is a importance performance matrix or importance impact performance map or priority map analysis. So these are the different names of the same technique. And if we go ahead, so here it is written that the standard PLS analysis provide information on the relative importance of the construct. As we know, that means in our model, there are different type of the constructs are there. Some are dependent constructs, some are independent constructs, some of the mediator model. So many constructs are there. So now we have to find out the which construct has a much more importance, or which construct is a much more its performance is better than the in relatively with the other construct in your model. So now it's a construct explaining the other constructs in case in relatively with other constructs, and then information on the importance of construct is relevant for drawing conclusion. It's very important through which we can draw the different type of the like the conclusion by applying the IPMA technique on our model. In this regard, first, another thing is about the conclusions can be drawn in the 2 dimensions. So now there are 2 dimensions are there is already these are importance and in the performance. So these are 2 dimensions. Based on these 2 dimensions, we can conclude regarding the prioritization of our major actions. That means that if any construct is important and another construct is its performance is good, then okay, we have to decide, we have to make the certain like the major action depend on this one. Of any construct performance is not good, but it's important then what we should do to enhance the performance of that construct. So now these are the managerial decisions. So this technique is very important for getting the major actions. And then here the goal is to identify the procedures and the target construct. These 2 important concepts are there in the next slide. There's one model through which I will tell you the visa what is the difference between the procedures and the constructs. And then those have a strong total effect. And then another thing is a total effect. I will also tell you the total effect. And relatively low performance. If someone's important, like the effect is much more, but its performance is very low relatively, means in comparing with the other constructs. So now, so here our model about which I was talking. So in this, you're looking, this our target construct. So this is our target construct. And Y1 and the Y2, these are our procedures, and this one is also our procedures. So all these are our procedures constructs. So here there are the 4 constructs are there. 3 constructs are our procedures, and the Y4 is our target constructs. So there we also discuss about the total effect. So now total effect means the addition of the direct effect and indirect effect. So now what will the direct effect? Now this arrow shows the direct effect. direct effect of the Y1 on the Y4. This was also direct effect. And now this is a direct effect of the procedures on construct, procedure on construct. This is also direct effect, but this direct effect is of the procedure to procedure. So that's why that means it's not we're not interested in this one. So now this is the direct effect, and indirect effect this one. First we are there is the checking the effect of the Y1 on Y3, and from there we are then checking the Y3's impact on the Y4. So this is called the indirect effect. So when we combine the direct and indirect effect, it's called the total effect. And then in this one, in the last figure, Y1 is a particularly important to explain the target customer 4. In the last one, Y1 is a explaining particularly the target construct Y4. And then it means that the one unit increase in the Y1's performance increase the performance of the Y. That means when if there's increase in the performance of the Y1, that means up to the same one, there is a increase in the performance of the Y by the value of the total effect of the Y1 and Y4. So here it is a 0.84. Second bit was that means if the other things remain same, this will happen. So now, dear friend, this is also type of the linear type of the technique. So therefore, linearly we have to check the impact. And then here you're looking at since the performance of the Y1 is relatively low, there is a substantial room for improvement. So as the performance of the Y is a very low in comparing the other constructs. So therefore, what there is a one room, there is in this regard, managerially, we can decide that we can improve this one. Now it may be your employee performance Y1 may be construct of the employee performance. The performance of employee is very low. So now this is the area, this is a room where we can improve your performance. And now here it's a relevant for major action. So now it is a there is a performance Y1 construct is a one where you there is a more major actions are required to improve its performance. And another thing is about the while in this introductory IPMA on the construct level, we can also do at the indicator level. At the both level, we can perform. So rightly, there is not only construct level but also indicator. Now, I think you know the difference between the construct and the indicator. Otherwise, not then the here with image is available where the construct is also there and indicators are also mentioned in this. So now, these are the step number 5. Step 5 steps are there through which we can construct the IPMA map. So these 5 steps are here. And then here, the PLS-SEM draws that the IPMA results offer important insight in the role of the antecedent construct. Now you know about the antecedent construct and the target construct. So now basically we use this technique for our managerial actions. So now which construct we should improve. And then another thing is about the IPMA becomes particularly useful when we are working on the multi-group analysis. So multi-group analysis like the different, like the male or female, like the age, different age groups are there. Like the, if you work on the international level, then you may select some sample from the different countries. So now these different countries are also a multi-group. Now, like the on ethnic basis, on the religious basis, you can also work on the different multi-group. And now, especially if you are working on the multi-group groups, then this one is very important. And then there is no comprehensive tutorials are available on this like the technique and are step by step some of the is like we can say the material is literature is not available. So that's why this one is little effort to fill this gap by providing this type of the tutorials to you how to apply this technique on your data with the help of the SmartPLS. And then another thing is again that these 5 steps are there. So now one by one we are discussing. First, our step is a requirement check. So now whenever you are required, when you want to apply the IPMA, first we are required to check the requirements that either the technique which are uploaded, the date, like the model on which we want to apply the IPMA, either that model is fulfilling all these 3 requirements or not. So the first requirement in this one is that the first that rescaling latent variable score. That means the scale of latent variable throughout all the clusters should be same. Like if you're using the 5-point Likert scale, then throughout all the scale scaling approach should be same, and it should range from the 0 to 100. So now metrics, if you are using the metric or quasi-metric, but your scale should remain same throughout your construct. Second, the requirement is that all the indicators coding must have the same scale direction. Okay, same scale direction. And then, for example, minimum indicator must have the most outcome. Like you're looking here, that in this image, it is looked at the one is strongly disagree, and the five is strongly agree. Now, if you are following the 7-point Likert scale, then the first should be strongly disagree, because minimum value should be worst and the maximum value should be the best, like the 7 should be strongly agree, or 5 should be strongly agree. This is another the requirement. And another requirement is that regardless of the third one, the measurement model, whatever measurement model is there, is that there's a formative or reflective, that we have to consider the outer bits must be positive. Now, either you're working formatively or reflectively or mix of the construct is there, but we should focus on the positiveness of your estimate. That means your estimate outer bits, especially those, should be positive. Now, if we talk about the formatively, okay, we can work on the, normally we look at the outer bits, but in case of the reflective measurement model, we normally look at the outer loadings. But in this case, when we are applying the IPMA, then forget the outer loading. First, just focus on the outer bits. Either you are working the formative or reflective measurement model. And then another important thing is there that if the outer loadings are not negative, then our score will not remain within the 0 to 100. Possibly, if the someone is in the negative, then our score will be minus -5 to positive 95. So in this way, we are out of the range of 0 to 100. So that's why it is important that our outer weights must be positive. And then another thing is finally, negative outer weights might be the result of the high indicator collinearity. If there is any indicators weight, outer weight is in negative, then you must be sure that there is something multi-collinearity or collinearity in your among your indicators. So reason how to identify this one through the VIF, variance inspection factor. If anyone's indicators value is 5 or more than 5, then probably there is a multi-collinearity. So it is better to exclude the same ones from your analysis. So now here the IPMA can be applied on any type of the path model. No problem. It's not either there is a formative or there is a reflective. On any one you can apply without any problem. And then, so when conducting IPMA at the indicator level, the mean of the indicator value represents its average performance. So when you're working on indicator level, then its mean value is it is average performance. Okay, another thing is about when computing the average values, the construct or indicator level is important. The indicator maybe like the measured on the different scale. Now the scale are from 1 to 5, 1 to 7, or 1 to 9. But here we are performing they are calculating their average. So in this regard, table 4, okay, it shows the mean values only. How? And then in our example, Y1, the mean value of the performance, this of the performance, like the 53.7, Y2's mean value is 85.6, Y3's mean value is 61.84, and Y1 is stand at the 78.1. These results serve as an input for the importance performance performance dimension. These are different dimensions of the important performance made. So these will serve as a the values for the important performance made. So based on these values, we will analyze our important performance made. So here you're looking, these type of the values are there. So these are the 4 indicators are there, and these are the mean values of all these ones. So these are constructed. So all these are their indicators. Okay, so now based on these one, these are the our average of all these our constructs. And then according to the a construct's importance in terms of the predicting either directly linked or indirectly linked target. Now, one construct may be directly linked with the target construct or maybe indirectly linked with the target construct. A model is derived from the total effects, okay, of the relationship between two constructs. So now, if we talk about the total effects, it means that we have to combine the effect of the indirect effect and the direct effect, and then the total effect will appear over there. Total effect means the effect of like the relationship between the two constructs. So here you're looking now that you know with the direct effect now, like the for example, in this one you're looking here, it's a direct effect. So now this is clear direct effect. Zero point 0.5 is direct effect. Now again, this is also clear that the 0.5 is another direct effect. When we talk about the indirect effect, then these are indirect effects. Sorry. So then these are our indirect effect. Y1, now the Y1, Y2, this Y2 and the like the Y3, okay, Y2, Y4, and then Y1, Y2, Y3, and Y4. So these are different indirect effects are there. So now the total effect are derived from the direct effect and the indirect effect. And then another thing is about the IPMA works on the unrestrained rise effects OLS. For example, if you work on the in the species now, or we are working on the multiple regulation. Now there is a model sum in the models, not model sum, but another table which is like you're looking here. So in this one, unrestrained rise and restrained rise both are available here. So normally for our, we consider the unrestrained rise effect. So like in the OLS, this happens to like the precedence construct impact of the target construct. So how much there's an impact of the precedence on the target customer, this we know through the unrestrained rise effect, like in the OLS in the species. And then more precisely, by drawing the unrestrained effect, we can conclude that the increase in the certain procedures construct performance would increase the target performance constructs performance. So now if there's an increase in the procedures, the up to the same level, there will be also increase in the target constructs. And then in this one, there is a they determine the significance of the total effects. That a total effect is it is significant or not. Like the p-value, computing the p-value of that one, we have to use the bias protect accelerated BCA approach by applying the bootstrapping technique. So now, SmartPLS is basically it is a like we can say the non-parametric technique. So in order to test either to get the p-value of our hypothesis, we apply the bootstrapping technique. So through the bootstrapping technique, we can know the significance of the total effect. Total effect is significant is or not. So now through the bootstrapping. So in my earlier videos, I have discussed about the bootstrapping. And then here looking at the first step, like step number 4, that's about the important performance creation. When you want to create important performance, the first step is about that the IPMA requires selecting the target construct of this interest. So in our example, Y4 is our target construct. So here first off, we have to create the target construct. So Y4 is the target construct, and these two are our these three are our preceders are there. Is important to distinguish between like this one. Like in other technique, like in the other, like we decided this is what is our this my dependent variable and these are my independent variable. In this way, we have to decide this one. And another thing is about the table 4. This is our table, sorry, there is a table 6, summarize the values of the MAP and So now these are some of the values which we will refer while developing our like the they means our MAP, importance performance MAP. So these are the values of the important performance, and these are the values for the performance. So we're looking here, these values are for the Y3 to Y1 to Y3, but there is no any value of the Y4 because Y4 is our target construct, and from Y3 1 to Y3 these are our like the preceders. So this is our mean value of all these ones. So based on these one, we will decide about our data, which our scale is important and which scale is its performance is good. So, dear friends, we have reached on step number 4 in this one important performance map creation. You're looking here, the one map has been created. So here performance, and then in this side there's importance. So these are our location of our y1, y2, and y3. You're now looking the construct y4 because construct y4 is our target construct. So therefore it is not appear. It's not being appear. It's not available here. So now if now here there's a figure number 4. In this one, this talks about the important adjusted important performance of the map, like the target construct 4. So now here you're looking at the this is our performance, same thing, this is our importance, and this is our mean of the importance and the mean of the performance. So now you're looking here two important things which are not available here in this one, like the this is our line, this is our mean line, and this is another our mean line. So these two mean lines are there, and now we will locate the means of which where our variable are locating. Now, for example, here this one is locating here. This one is now y3's location is this one, y1's location this one, and y2's location is in the upper corner. So normally, generally we can say that means that whenever anyone's location is variable within this one, it's a wonderful. From this importance point of view, from performance point of view, it's a wonderful. It says no any problem because this one like the mean. So now mean 0.55, that means it is higher than 0.55, and another mean is there. This one is another mean 67. Then again, it is higher than the 67. So from the importance and from performance point of view, the Y2 is very important, and where its performance is very good. So, but for other things, if we know, that means you're looking here one image. In this one, in our example, the performance, important performance map of the figure 4 shows that the Y is a relatively low performance 50. So Y1 is a relatively low performance in comparing the like the others Y2 because its performance is like it is falling. There is a 53. It is like it's a below than our mean. It's a quite below. There's our mean is a point like the 67, but the performance of this one is about the like the 53 point something. So now the Y1 is a quite low performance from this point of view. And if we go ahead on other with the total effect of the 0.84, this construct importance is particularly high. But from the importance point of view, its importance is very high. How? Because now see, then is that this is exactly falling from the 84, something like this one here. So now quite away, quite higher than our mean. This is our mean 0.55, and here its value is a 0.84, so quite high than our mean. So from the importance point of view, Y is good, but its performance is not good in comparing the Y2. So it means that one unit increase in the Y1's performance, 53.54, would increase the performance of the Y4 by the 0.84. So if you increase its performance from the data from the this one to this one, if 1% increase, then the 0.84% will increase in the Y, like in the target construct. In this one, we can that means the interpret the results of this one. When the managers aim at increasing the performance of the construct Y, their first priority should be to improve the performance of the aspect of the Y. So now here decision making, one decision making is that means whenever the means the managers they want to increase the performance of the Y4 like this one, then they need to enhance the performance of the Y1. So now they look at the Y1. If they will enhance the performance of the Y1, automatically the like the construct Y4, which is a target construct, its performance will be increased. So probably the construct Y1 maybe an employee performance, its performance is very low. So now this is the area where the Mr. Manager should focus on this one. In this way, this may guide the researchers, they means how. And then, okay. So now the aspect related to the construct Y2 and Y3 follow a second and third priority. So Y2 and Y3. So that after that one we'll think about this one. Okay, now this is here and this is here. So now from the performance importance point of view, its importance is not good, its performance is good. So, but this one is from both point of view, it's a wonderful. So in this way, we can interpret our importance performance map. So here, same whatever I have told you in the last one. So IPM is not limited to the construct level. Only the construct level we cannot work, but we can also work on the indicator level. So now here the reflective measurement may be whatever, but in this regard we will only focus on the outer weights, not on the outer loadings. And then, while outer weights play no role in the assessment of the reflective measurement model, normally, we say in the measurement model, there's no role of the outer weight, but there's a due role of the outer loadings. So now for reliability, validity, it says no. So still each indicator's contribution performing. So still we will consider in case of reflective only the we will focus on the outer weights, especially when we are applying the IPMA on the indicator level. So here looking, this is the extension of the IPM5 indicator level. Okay, here this is our example. Practically how the IPMA has been applied in this paper. So now this example is here. I'm not considering here to discuss in this video because after if I consider that the length of the video will be very high. So now I have discussed the empirical example in the video lecture number 34. And after that one, so now this is another book. There's also a one chapter on the IPMA. So if you're interested in this one, so here this library web link is available. Share library from there you can easily in the free of the class you can download this one. Thank you very much. At the end of this video, I hope you have watched this video completely, and so many of your concepts have been clear, theoretical concepts have been clear regarding the IPMA. So at the end, I request you please subscribe my channel and please communicate the information about this channel to the rest of the people. Thank you very much.